Hello everyone, good morning. So welcome to my session today on Are you up to date on functional safety software best practices? This topic is of high importance today. The reason is that if you look at any of the domains like automotive, industrial applications, medical devices, or rail signaling, we know that everywhere the systems are getting connected and we are concerned about the functional safety of these systems. So we need to make sure that the functional safety related to software also has been addressed. So in this topic, we are looking at whether we are up to date based on the process standards while we are developing the software for functional safety related systems. So let us look into the agenda for the meeting. So we will start with discussion about trends in embedded systems across different domains. So we will be having a specific focus on automotive domain, industrial domain, and consumer electronics. And then we will deep dive into the lifecycle requirements for safe and secure application development. And also we will discuss in detail about the verification and validation techniques and methods that is applied across the requirement verification stage, design verification stage, as well as code level verification stages. And also we will see the role of tools and how these tools can be integrated and how we can use qualified tools and what are the benefits when we use a automated, qualified and integrated tools in the life cycle development activities. And also we need to summarize it with what is the return on investment when we are using automated tools, which are certified tools in the life cycle activities. So now let us talk a little bit about dependability. So in earlier days, we were looking at developing or manufacturing dependent products. Dependent products means the dependability has been defined in terms of various matrices. For some people, it is based on availability of a product or software whenever they are in need. And for some of the people, the failure rate need to be very less. So they don't want failure to be occurred for any of the components. So it can be random hardware failures or systematic failures. So they need to reduce the failure and make sure that the product is reliable enough. And reliability has been an important aspect for looking at developing a dependable product. And later on, all these products were having a lot of updates and upgrades. So maintainability has also become one of the metric while looking into a dependable product development activity. So during maintenance of the product, we will be looking at what are the existing features available in the product and does these existing features are impacted due to any of the new additions or changes that we are doing into the existing product. And in the recent times, we have been seeing concerns about safety also. So today we know that when we look at any of the embedded applications in automotive, industrial applications, or in consumer electronics, most of this embedded device has an impact on life of people, environment, as well as on the people who are around these systems. So definitely there is a concern on safety and all these systems has to operate in a safe manner. So safety has also become one of the aspects for considering a dependable product development activity. And in today's world, we know that most of these embedded systems are getting connected to the external world or in the intranet. So many of these systems are communicating each other, they are collecting the feedback and they are trying to work as much as possible to improve the efficiency, to improve the other factors like quality or to improve the ease of usage or to port the systems between different platforms. So because of all this purpose, the systems are getting connected and they are communicating to each other, and security has also become a concern for developing a dependable product. So dependability means it is the ability to provide services that can be defensively be trusted within a time period. So now let us look into the traditional way of developing a quality product versus how a risk-based approach is followed today in order to develop a safe and secure product. So during a quality-based approach, we were looking into the product quality and the end users were much concerned about the quality in use. So when people were developing quality product, they were looking at how secure is the product, whether all the functions are available, features are available, and how reliably they can use it. what is the ease of usage, whether they can port it, modify it, how efficiently they can use it, and can it coexist with other systems in the ecosystem. And when it comes to the quality in usage, people were looking at, the end users were looking at how effectively the product can be used and what is the efficiency and whether they are satisfied with the usage of the product and is it free from any kind of risk which is directly related to people or environment. And also the contextual coverage where intended and potential coverage for quality has been addressed. And from this quality-based approach, today, when we are talking about safety and security, the risk assessment during the concept phase of the products drives the priority for developing the safe and secure product. Because we need to do a risk assessment to address all the risk associated with malfunctioning of the product and whether it is related with safety of people, environment, or system itself. And also when it is connected to the external world, a threat analysis and risk assessment has to be done where we need to identify the risk and we need to prioritize the risk, classify it, and we need to make sure that the risk mitigation goals are available, and this has become part of the security requirements. So safety requirements and security requirements are derived from the assessed risk and mitigation goals, and that will be the driving factor for developing a safe product or a secure product. So layers of protection or defense in depth will be implemented within the product to ensure that the product is safe and secure. So now let us look into the anticipated automotive world. So if you look at the automotive world, we can see that many things are happening in the automotive world, including the autonomous driving. So we are at level 2.5 autonomous driving, and we are striving to get into the level 5 autonomous driving, where even there is no driver seat or no steering wheels or no pedals available, and completely the car will be on its own. And we can see that mobility is coming as a service where on demand the cars will be available to us and we can use it, and they may be charging per usage. And similarly, a lot of data security and protection related things are embedded into the car itself. And there is a predictive maintenance, like today's electric cars. If you look at, you get the apps, and within the apps you can see that the diagnostics you can do it, and you can see that similar to the laptop, how we do the diagnostics and identify the issues. You can identify the issues which can come up in the future, and you can take mitigation activities right now itself at an early stage. And even the purchase process is completely digital nowadays, and there is connected supply chain and manufacturing available. So there are a lot of things which are happening, and some of the things are listed down here. So it's a complete transformation which is happening, and most of the things are based on software. So it may be software which is in the IT, or it may be software within the embedded systems. So now if we look at the process standard ISO 26262 overview, we can see that 26262 has clearly mentioned about the life cycle activity, right from the management level activity to the product development level activity. So the product dependent activity consists of the concept phase, where what are things you need to consider during the concept phase of the product. And also it talks about, at the system level, there is a bigger V model which talks about how do you create a technical safety concept and how do you ensure that all the safety mechanisms are inbuilt into the product. And the detailed activities for the hardware development and software development are described in the smaller V models. So this process guideline is a set of good engineering practices which will help us to develop a safe system. Similarly, in other domains also, there are process standards. For example, in the industrial domain, we have IEC 61508, and ISO 26262 is developed based on IEC 61508. So we can see that a clearly defined process guideline is available for us when we are into product development activities. So what we need to take care of? We need to take care that these process activities are tailored according to our needs, and we are following the process activities, and we are generating the evidences to show that the process activity is followed, and we have completed these activities, and the evidences are available so that we can certify the product. And also these process guidelines provide you a safety life cycle. So the intention of the safety lifecycle is to make sure that the safety activities are performed right from the beginning stage or concept stage of your product. For example, this is a safety lifecycle from ISO 26262 guidelines. So you can see that during the product definition itself, we start the safety activity where we can do a impact analysis in case if it is a legacy system and if we are upgrading the system, or in case if it is a new system, we can directly go to the hazard analysis and risk assessment to identify the hazards, prioritize the hazards, and classify the hazards. And the mitigation mechanisms can be either allocated to a different technology, or we can take external measures, for example, having the crash barriers on the road, or having the firefighters in a tunnel. So these are some external measures which will be used to overcome the risk. Or we can have controllability features built within the uh, system itself, which will prevent from a failure, or which can actually indicate us about a failure in advance. So this is the safety life cycle which is given by ISO 26262, and ideally we are supposed to ensure that these safety life cycle activities are performed, and verification plays a major role while following the safety life cycle. So if we look at the other domains, it is quite similar. We need to ensure that the safety activities are performed right from the beginning to the installation, operation, service, and decommissioning of the product. So there are few differences in each of the domain, but most of the time these activities remains quite similar. And let us look into another example of industrial applications. So how do we develop safe and secure industrial applications, where we need to have a look at what is Industry 4 and what is a demand from Industry 4. So we all know that during the first revolution of industry, um, water power and steam power and lot of mechanical things were used. And during the second generation, so they were concentrating on mass production and assembly line because electricity was available. And during the third generation, computer and automation, like we can see that today most of these process activities are automated. And in the fourth generation, we are talking about connectivity. So from automation to autonomous. So that is a change which is happening from third to fourth generation, where we need to collect the feedback data, and we need to make sure that the feedback is taken and corrective actions are taken. So we are able to improve the efficiency of the systems which are implemented. So we are using a lot of data algorithms, and we are storing a lot of data, and we are trying to make sure that there is an optimal solution for every single events which are identified, which is reducing the efficiency or quality within the process. So that is the idea of this implementation of cyber physical systems in the fourth industrial revolution. So now let us see an example of how exactly these things are working. So we have a physical layer. The physical layer actually consists of sensors, actuators, or microcontrollers or tracking devices. These are usually called as endpoint devices. For example, if you have a flow of a liquid, basically you may be having a flow meter. So the flow meter is capable of analyzing whether the flow is within the range or out of range. Or sometimes you may have sensors like LDRs in the car, so which can sense whether the object is quite near to the car and what action need to be taken by the car, right? So these are called as endpoint devices, and these endpoint devices will be collecting the data, and sometimes it may do a one level of processing using the microcontrollers along with the endpoint devices, and it may be passing this data to the networks. So the network consists of different protocols, and from the network layer it will be passed to the data storage. So you may be using file distributed storage such as Hadoop, or it may be on a local server, or it may be on a cloud. So once the data is available, we know that what is happening in the process, and there may be algorithms which will be helping you to analyze the data, and you can actually provide what kind of a solution will be good for improving the efficiency and quality, or to safeguard the system which is actually running. So the application layer is nothing but the solution which is identified will be passed back to the physical layer, so the physical layer can improve its performance and it can work smarter. So this kind of a layered approach is being followed in smart factories, smart transportation,
smart health, or even in smart buildings. So everywhere we can see there are endpoint devices and microcontrollers are used. So there is a ton of software which is running in all these endpoint devices, which is continuously sending the data, receiving the data, and it is behaving according to the data which it is received to improve its performance, to make sure that the systems are safe and secure. So this is how a typical cyber physical system is working. So if you look at any industrial application, usually in industrial application, all these embedded systems may be supplied by a product supplier where he need to conform to the IEC 62443 Part 41 standard. So IEC 62443 talks about secure application development lifecycle. So it can be a component, or it can be a system, or it can be an application which is supplied by the supplier. And once you have these components available, so these components which is developed independent of the internet environment can be configured for a industrial application, industrial automation and control system, which is the IACS. So IACS systems will be using these endpoint devices or these controllers, and an automation solution will be implemented. So you can see that the automation solution may consist of multiple subsystems and one of the component which is supplied by the product supplier. And there is a system integrator. The system integrator's role is basically to ensure that all these subsystems are integrated and the final process solution is available to the asset owner. So the asset owner basically operates all these systems, and different parts of IEC 62443 is being followed by the system integrator as well as asset owner. So we as embedded developers, we are mostly concentrating on the product supplier, where we need to follow IEC 62443 part 41 and part 42, which defines about the secure software development lifecycle activities. So now the lifecycle requirement for safe and secure application development, we can have a detailed look. So we understood that what's happening in the automotive industry related to the process standards, and what are the requirements of industrial applications with respect to safety and security. So if you look at the process standards, there are process guidelines available for improving the quality of the product. For example, IEEE 12207, which talks about the lifecycle requirements for developing a software product. There is MIL 498 standard, CMMI standard, TMMI, ASPICE for the automotive, AS 9100 for the aerospace industry. And if you very specifically look at the safety related application development, we have the DO 178B or C for aerospace software, the ISO 26262 standards for the automotive software, and EN 50128 for the rail. And safety of the internet functions for autonomous cars are defined by ISO 21448. And for industrial applications, we have the 61508. The medical devices have 6244. Sorry, it's basically 60302. So I did a mistake here. And for the automatic controls, we have the 60730. And for HVAC, we have the 60335. So you can see for every domain, there is a respective safety standard available. And it is the duty of the developer to ensure that the safety standards are being followed. So most of the times, it's not a statutory requirement, but we need to ensure that due diligence is be taken care while developing the product. So we need to follow these standards, and whenever there are issues, we have legal binding whenever we are following these standards. And for security also, you can see there are a lot of standards like ISO 27000 series for IT related applications, and DO 326 and 356 for aerospace industry, the SAE J3061 for automotive security, which is recently being upgraded with a different standard, like 21434, ISO SAE 21434, and 62443 is for industrial application. And there are a lot more standards for medical devices security, and related standards are coming up. So we can see it's the security domain is completely getting evolved, and we need to be prepared for developing a product which is safe and secure. So now let us look into the similarities and differences between the system safety and cybersecurity, because most of the times it is confusing for the users to understand about system safety and security. So when we are talking about system safety, If the product fails, it shall not create any harm to life, property, and environment. So this is what we mean by system safety. And when we are talking about cybersecurity, because we all know about the traditional cybersecurity, which talks about web-based applications. Okay, so in web-based applications, in case if there is a hacking or if there is a threat, the losses are related to financial, operational, privacy, or data-related losses, right? But we are talking about safety loss. Imagine about a connected car which is being navigated based on the inputs that is given by the user. And at some point of time, if somebody is able to take control of your car, he can increase the speed, he can decrease the speed, right? So that means the hacker who has taken control of the car is a threat to the life of people who is sitting in the car, as well as he is a threat to the life of people on the surroundings, maybe for a pedestrian, right? So that means now a security issue, the impact of the security issue is basically a safety related problem. So for embedded system, this is what is happening. So we are not much concerned about the financial, operational, or privacy laws related to the web-based application, but we are also concerned about a cybersecurity issue can have an impact on the safety of people, property, or environment. So this is what we need to protect by building safety and security into the system. So remember that all safety critical systems are cybersecurity critical in case if it is connected to the external world. But all cybersecurity critical systems may not be safety critical. So an example is an entertainment system within a car. If it do not have any connectivity related to the navigation of the car, then if somebody hacks the entertainment system also, it's not an issue. Unlike the Jeep Cherokee case where we all know that people were able to get into the canvas of the Jeep Cherokee and they were able to drive it remotely by taking control of the car. Okay, so such kind of situation can also occur. So now we need to understand about what are the process activity difference between safety and security scenario. So functional safety, in case if you are following IEC 61508, right from the product concept, the process standard need to be applied. Similarly, we can tailor the process for cybersecurity requirements in industrial applications according to 62443 part 41. So once the product concept is defined and the scope is available to us, we can start the safety and security activities. So the safety activity includes performing a hazard analysis and risk assessment to ensure that all the operating conditions and operational scenarios are identified and we are able to find out the risk, list out the risk, and we are able to prioritize which risk is having more problem. So this way we can prioritize the risk, and we can also define safety goals which will be able to prevent, control, or mitigate the safety related risk. And the mitigation activity is nothing but it will be formulated as a safety requirements, because we need to build in some mechanism which will do this mitigation activity, which will be part of the safety requirements. Similarly, for security also, we need to perform threat analysis and risk assessment, so which need to be done by an expert team, and we need to identify the threats, classify the threats, and we need to prioritize it. And once we prioritize the risk related to security, we need to define the goals which can actually mitigate this security related risk. And this will be part of the security requirements. So that means we may need to have a threat modeling available, and we need to have mechanisms which will prevent the threat to be active in the systems which we are operating. Now, going to the detail of the product development from a system concept to the software lifecycle concept. So you can see that we will be specifying the requirements in detail, and we will be realizing it, which consists of the V models which we have seen as an example. And once the product is realized and once it is complying with the safety requirements and security requirements, we will be having the installation and commissioning, and the overall safety security validation, and the overall operations maintenance and repair related activity, and finally the decommissioning activity need to be planned. So these realization, installation, maintenance, and decommissioning activity need to be as per the safety integrity levels. Safety integrity level means in case if the product fails, what is the impact on safety? If it has a higher impact, it will be on a higher SIL level or it may be on a lower SIL level. Similarly, the security related risk need to be identified and the product need to be defined with the security level starting with level 1 to level 4. Level 4 being the highest one and level 1 being the lowest one. So depending on the scenario of where the product is getting installed, what are the failures it can happen and how these failures can have an impact on life, property or environment. So once you do this analysis, you can actually classify your product into a safety integrity level as well as a security levels. So in safety, we are performing a defense against random and systematic failures so that there is no harm. And in security, we are performing the defense against negligent and willful actions to protect the devices and facilities. So I hope now you understood about the similarities and differences between a safe application development and a secure application development. So now let us look into the details of the process activity and what are the challenges. So we will take the automotive standard as an example and let us see what are the challenges on path to design a safe and secure automotive application. So the primary thing is that we need to ensure that we are able to trace all the requirements and no requirements are missed out. So people may be using requirement management tools or you may be writing your requirements in Word or Excel or PDF and you may be having requirements at multiple level. For example, you may be having your business level requirements, your system level requirements, your technical safety concept, technical safety requirements, your software safety specifications, right? So these all are requirements at different levels and you need to ensure that all the requirements are traced and none of the requirements are missed out. So traceability is an important aspect and it is a challenge and tools like LDRA tools can help you to overcome that. And the next activity is while developing the product, you are following the safety standard and security standard. So every single objective in the life cycle activity need to be tracked and you need to have evidence for it. For example, you are doing a requirement verification. You need to ensure that requirement verification is performed and the evidences for requirement verification is nothing but a traceability report which shows 100% forward and backward coverage. So this is one of the evidences. The second evidence is a peer review report, which is done by one of your peers. It can be an informal one or it can be a formal one. So you can do inspections, you can do reviews, formal reviews, and this becomes the evidences for you. So the objective tracking for requirement verification is nothing but the review reports as well as the traceability report. So these reports need to be available to you. Similarly, every objective in the lifecycle activity, you need to have sufficient and convincing evidence and you should be able to demonstrate it. And during the coding stage, coding standard compliance, you need to tailor a coding standard and you need to make sure that coding standard compliance is achieved. Data coupling and control coupling analysis for higher safety integrity levels like SIL level 3 or SIL level 4, you need to ensure this analysis is performed and you are able to demonstrate it. Structural coverage, including statement coverage, branch coverage, MCDC coverage, need to be analyzed and it has to be 100%. And for higher critical systems, target testing need to be performed because testing on simulator is not recommended due to memory related and timing related issues. And in case of aerospace applications, an object code verification need to be done, but for other domains, object code verification is not recommended. And the tools which are used in the lifecycle activity need to be qualified ones, and the complete compliance management need to be performed as per the tailored process. So once you have these evidences, the software or system can be tested and confirmed to 26262 or 61508, which is industrial applications or any of the standards. So these challenges we can overcome by the use of automated, qualified, and integrated tools in the life cycle, which will help you to reduce the cost of compliance. And also you can manage a distributed team with the application of the tools, which will finally help you to reduce the time to compliance and market. So now let us see some example of how do we accomplish these process objectives, what testing techniques need to be used, and how do we generate these evidences. So let us look into an example of the automotive industry where I'm talking about the specification of software safety requirements. So there are primarily two activities which comes up as part of the specification of software safety requirements. The inputs may be taken from the system level technical safety requirements or technical safety concept. And based on that, we are supposed to develop the specification for software safety requirements. So it includes the specification activity as well as the verification activity. So verification starts right from the requirement stage itself. So you have requirement verification, design verification, code level verification, unit testing, integration testing, and testing of the final embedded software. So these activities need to be completed, and the objectives which are recommended by the process standards need to be fulfilled. So artifacts and assets. Artifacts means basically the evidence what we are generating. Assets means the input documents what we have. For example, if one of the objective is to ensure that the source code is conforming to coding standards, the asset is nothing but the design and coding guidelines which are based on MISRA, CERT, or any other coding guideline. And the artifact is nothing but a code review report generated by the tool to show that the coding standard is conformance is established. So this is how every objective you need to track, and you need to make sure that the assets and artifacts or evidence for each of the objective is available. And all the testing activity need to be done based on the requirements. For example, the system requirements can be used for a hardware or software integration test. The software high-level requirements can be used for a software component integration test. And the low-level requirement can be used as an input document for unit level testing or low-level testing. And in case if you are performing object code verification, it need to be directly traceable to the source code. So this is how all the test has to be based on the requirements, and there should be vertical traceability and horizontal traceability established between the requirements and the test. So if you have an automated tool, you can see these are the reports generated by LDRA tool suite, which confirms that the low-level requirements are fulfilled. You have mapped functions for the requirement, and you have mapped test cases. So every requirement need to be verified according to the test plan, and you should be able to establish traceability. So this will help you to reduce the cost and time of maintaining the traceability and impact analysis. So here you can see an example of ISO 26262 requirement specification. So the process standard talks about specifying the requirements in a natural language or by using semi-formal notations. Basically, you can write it in simple English using the Word document, or you can write it in requirement management tool. But the thing is, in either of the way, the characteristics of the software safety requirements need to be adhered. So the requirement has to be atomic in nature. It has to be internally consistent. It has to be feasible to achieve. It should be verifiable. Necessary information should be there. It has to be unambiguous, and it has to be implementation free. And the verification activity you can see here, verification activities are defined in a table which talks about walkthroughs for lower SIL level. If it is highly critical application, you need to do the verification by inspections. And formal verification is just a recommendation. If you have formal tools, you can do it. Otherwise, semi-formal tools using semi-formal verification can be done by using automated tools. So traceability plays an important role in verifying the software safety requirements. So ensure that the traceability, you are able to establish it and you are able to show it as an evidence. So this is one of the screenshots from LDRA's TBmanager tools module, which gives you the traceability of the requirement document. So you can see from system level requirement to high level requirement to low level requirement, you can establish the traceability reports, and also the test unit level, integration level, or system level test are performed based on the requirements. So vertical traceability and horizontal traceability, we can show you with the tools by integrating with the requirement management tools like IBM Doors, Jira, JAMA, Codebeamer, PTC, Silk Road. So there are a lot of requirement management tools, and we support all of these tools. Or even if you write it in Word, Excel, PDF, we can support it. So this is one of the example for traceability metrics report. You can see from system level requirement to high level requirement, one-to-one, one-to-many, or many-to-one relationship you can see. Wherever you don't have a relationship, the tool can show it in the report because this report will be less than 100% because one of the requirement is not completed here. It is not mapped with any high level requirement. So this way easily the user can identify it and establish the traceability report. Now coming to the design stage, in design stage also 26262 talks about the design principles. So some of the things are like the design has to exhibit modularity. So in case if it is in a modular way of a development approach, in case if you need to upgrade the systems, it is quite easy because you can pull out one module and you can plug in multiple modules. An encapsulation where the common items need to be binded together, and simplicity, that means we need to reduce the complexity of the systems, and we need to have a layered approach in developing the system. A hierarchical model need to be followed, or a structure need to be followed in developing the system. So it also gives a table which lists out a lot of design principles, and most of these design principles are highly recommended for SLD, highly critical application, and for less critical applications there are few recommendations and few of the things are highly recommended. And looking at the verification activity for the design, so you can see simulation of the design is a recommendation, but it is highly recommended for SLD. So if you have modeling tools, you can do the simulation. If you don't have the modeling tool, most of this verification activity like data flow analysis, control flow analysis, which is highly recommended for SLC and SLD, you can perform it only when the code is available. So usually for A, B, and C level applications, you may not be having a modeling tool. In that case, once you have the code, the data flow and control flow analysis can be done, because this is one of the verification activity which is highly recommended for highly critical systems. The challenge is, how do we do all these activities? Okay, so I will show you the reports which will complement from LDRA toolsuite to use it as an evidence for these verification activities. Now coming to the unit design and implementation, again there are design principles while doing the coding. So you can see the design principles for coding listed in this table, and we need to follow these. We need to choose the principles from this list, and we need to tailor the standard, tailor our design guidelines, and we need to make sure that we are generating a code review report which will show that none of these principles are being violated. So MISRA C reference, you can see it is being given here. For C language, we can follow the MISRA C. So this is and again a screenshot from the coding standard compliance from LDRA toolsuite. So we have support for 15 plus coding standards, and most of the coding guidelines within these standards are fully implemented in the LDRA toolsuite, and it is completely customizable. If you want to create a custom set of guidelines from MISRA or from CERT, you can do it, and the output from these coding guidelines can be attached as an evidence for tracking your objectives. So here I am listing out some design principles and what are the rules in LDRA toolsuite which will help you to ensure that these design principles are followed. For example, no dynamic objects or variables. You can see that dynamic objects are created using the functions malloc, calloc, or realloc. Okay, so we have a rule use of banned functions, and we can add or remove the banned function list, so the tool can automatically detect the banned function which will be allocating dynamic objects or variables. And also you can see another rule which will support this, pointer not checked for null. So whenever I have a pointer, I need to ensure that the pointer is checked for null before the usage. So I'm trying to use it, but before that, I'm never trying to ensure that it is pointing to null. So null pointer dereferencing can be there. So that is a reason, because of these reasons, it is highly recommended to not to have dynamic objects or variables. And similarly, cyclomatic complexity and quality matrices, these are available in the tool, and you need to follow, you need to make sure that some of these software quality matrices, you are able to measure the quality for your software and you are able to show it as an evidence. So this is again a screenshot from the toolsuite which shows that what are the matrices available. You can customize the matrices. A minimal of 3 to 4 matrices need to be used to measure the software quality and show it as an evidence. And similarly, data coupling and control coupling analysis. So data coupling analysis is to ensure that when you perform a requirement-based test, there shall not be any unused data items. So we have the data coupling report, which will show you whether there is a unused data item. So you can see here in red color, the unused data items will be available here, which is pointing to a function. So within this function, after performing a requirement based test, one of the cases is not executed, and the variable name is airspeed. So airspeed in the case 2 is not executed, which is a unused data item. Similarly, control flow and data flow, we can see detailed report where tools will show you how much percentage of data coupling variable usage. There are 13 data couples. Out of that, few data couples are not used. So you can see in which function one data couple is missing here. That means I need to create an additional test case to ensure that this data couple is executed, and I need to observe that there is no deviation in the behavior while executing this test case. And also control coupling reports are available. The tool can analyze how many control couples are there in a file, and how many control couples are covered and how many control couples are not covered. So it gives you the call from this file datain.cpp to system.cpp, and there are 17 calls and 15 calls are covered. That is the reason it is 88%. So ideally 100% coupling need to be there whenever you do a software integration level test, component integration level test. And also the tool provides you the details of test case generation. So the methods are given in a table 8, where you can see the requirement based test case generation need to be done. So here is a screenshot of how the requirements are linked from system level to high level to low level. And it is also mapped to the functions in the tool suite. And the tool can provide you the traceability report. So where you can see the low level requirements, how many are covered. You can see at least one test case is there for every requirement, and some of the requirement do not have any test case. That means you need to create additional test case. So right now 66% is the requirement coverage, requirement to test case coverage, and backward if you see test case to requirements, it is 100%. So I have around 36 test cases available and 58 requirements. More test cases need to be created for some of the requirements which are missing. So this is the traceability table from low level requirement to unit test. So you can see for some of the requirement, unit tests are missing. So we may need to create additional test to ensure that 100% requirement coverage is there. And similarly, once you do the test, the structural coverage also need to be measured. Statement coverage, branch coverage, and decision coverage has to be 100% for higher critical applications. And we can also visualize it through control flow graphs and call graphs. So the call graphs give you hierarchical information of the functional dependencies, and the flow graph gives you the internal flow of the program, where we can see what is executed and what is not executed. So all these activities can be automated for different target environment. So we can perform all this testing automatically by using the LDRA tool suite. So functional verification as well as security verification can be done for robustness testing. And finally, in automotive application, it is also recommended to demonstrate that there is no unintended functionality. That means you need to ensure that function coverage and call coverage is achieved. Function coverage is nothing but number of functions which are covered based on a requirement based test divided by the total number of functions. So tool provides you report for function coverage. You can see here out of 52 functions, 39 are covered, 13 are not covered. The uncovered ones you can see here, which is nothing but the function coverage. Similarly, call coverage, the number of calls made by a function, you need to ensure that it is all these calls which are made by a function is executed. So here you can see total covered function calls based on a requirement based test divided by total number of function calls. So I can see here it is 80% because I have 85 calls, 68 calls are covered by the requirement based test, 17 calls are not covered. So in each file, I can see the percentage of coverage. Out of 16, 1 is not covered. Sorry, out of 17, 16 are covered, 1 is not covered. Out of 20, 18 are covered, 2 are not covered. So that's the reason the percentage is less. So it is quite easy to navigate and see that what calls are covered, what calls are not covered. And we can use it as an evidence to confirm that this objective is fulfilled according to the process guidelines. And also for security, we need to make sure that robustness testing is done. Robustness testing is nothing but we need to bombard the unit under test or subsystem under test with a random combination of input and make sure that it is not deviating from the intended behavior. So the screenshot here shows that LDRA toolsuite is capable of creating inputs for robustness testing. For example, we can apply min, mid, and max value for conditional statements for data types. We can also deal with the pointers, whether to add abuse cases like null pointer, or dynamic allocation of pointer, or a retained value for a pointer. So the functional use case may be pointing to a structure and accessing the elements as an example. But the abuse cases may be pointing to null, creating a physical memory, or pointing to a dynamic memory. All these will be abuse cases. So we can configure it and the tool can automatically create a reasonable number of test cases to ensure that the robustness testing is completed. So this way you need to develop, execute, and run the test cases, and you need to make sure that test cases are available for every low level requirement and test cases are available for every high level requirement, and test cases are available for every subsystem level requirements. So all these activities need to be completed and the compliance management need to be demonstrated. So the process compliance document, the certification licensing interface, if there are stages of involvements and audits, you need to make sure that the audit reports are available, checklist, or in case if training is required for the team, it has to be provided. So this is how the skill requirement for the safety critical and security critical development related activities are available within the team or within the organization, which is related to a specific product development activity. So this will help you to minimize the certification risk and the cost to certify your product according to aerospace guidelines, automotive guidelines, rail guidelines, or industrial application guidelines. So let us have the conclusion related to automated and integrated tools to overcome the challenges. So you can see that there are two kind of requirements when you develop the safety critical and security critical application. One is the product related requirement. Another one is the process related requirement. So the product need to ensure that the technical requirements are fulfilled. So every verification activity need to be done and verification review has to be performed. Verification review is nothing but the evidence generated for the technical requirement is sufficient and convincing. That's how a ideal product is developed according to the business requirement, which is inbuilt with the safety and security related needs. And when you look at the process is nothing but you need to ensure that you are following the life cycle defined by your process activity, and the evidences which are required by the process activity, you are able to generate it. So you may need to do functional safety audits and confirmation review. So confirmation review is basically to ensure that the evidences are available and it is good enough to be used as a process evidence. And functional safety audit is nothing but to ensure that the process activities are completed and you are not deviating from any of the tailored process activity. So product and process related activity, once it is good enough, you can do the final functional safety or security assessment on the product. Once it is validated for the safety or security, it can go for the production related activity. So this is an overview of how do you develop the product according to the process and finally do a safety audit or a safety assessment or a security assessment, validate the product, and it goes for the final production. So looking at the V model, we can see that for every system, we starts with the system architecture design where the requirements are being specified in any of these tools. LDRS TBmanager is helping you to establish the traceability and perform the requirement-based testing. And also it helps you to comply with the process activities, whether it be industrial process, automotive process, rail process, consumer electronic related process. It can help you. If you are using modeling tools, we do have integration with modeling tools. So LDRA toolsuite can initiate the modeling tool to generate the code and then it can perform unit test, integration test, or system test. Or if you are using an IDE or compiler, basically to write the code and manually and to compile it and link it for a specific target, we can perform the static analysis for the manually written code, and then we can go ahead with the unit testing, integration testing, and system level testing activity. So the LDRS TB Vision and TB Run module will be helping you for automatic test case generation and execution for different levels of verification for the code generated. So looking at the solution from LDRA tool suite, we have the basic module testbed, which can do the static and dynamic analysis. And on top of that, we have that completely automated TB run module for unit or integration testing. It can do the unit or integration testing on any target environment or on the host environment. We do have plugins available for Eclipse-based IDEs, Visual Studio, and for modeling tools like MATLAB Simulink or Rhapsody or Skate Suite or Enterprise Architect. And TB Vision is a complementary visualizer for the developers, where the developers can quickly pinpoint to the errors during the static analysis, and they can do the corrections and add there to the coding standards. And TBmanager is basically a collaborative test management tool where requirement-based testing can be performed, requirement traceability can be established, process compliance can be managed with the tool. So these are the modules which will help you to do the complete verification right from the requirement stage to the product certification stage. Now, there is a question when we are investing on this automated, integrated, and qualified tools, what is the return on investments? And whether this test process is adequate enough to ensure safety and security, and how much does it cost, and how do I do it? Do I need additional manpower with respect to my existing manpower? Do I need additional skills? Do I need any additional tools in the development chain? So these are some of the questions which comes to our mind when we are talking about safety and security. See, the answer to this is in my summary. So what we need to do during a safety related or security related process is we need to tailor the process activity as per the business requirements or need. So we don't need to completely follow the process activity, tailor according to your product need and aware of the testing methods and principles. You have a choice always. Look at the tables, pick up the activities and then do it. Evaluate the tool in advance to ensure the suitability, because you don't want to use all the features in the tool. You may need to use only limited features, so that you need to procure only limited modules within the tool. So a person who is doing a lower critical application do not need a data coupling or control coupling analysis. So he can skip those modules, evaluate the tools and use only the modules which is really required for him. So testing is part of a larger objective, which is verification and validation. So have this understanding. So what do you need to test it? What is the recommendation from process activity? What is defined in my tailored process? So look at this and do only testing which is really required for your product's need of safety and security. You don't need to do all the activities which are defined. So use automated, integrated and qualified tools, so which will help you to ease your certification. Evidence generation is an important aspect, and evidence generation need to be according to the tailored process. So make sure that you are following these guidelines, which will help you to ensure that you don't need additional skills or manpower for performing or developing a safety critical or security critical application. And you need only less cost in terms of investments for your testing activity, depending on what is the level of your criticality for safety and security. So if you remember this, it will be a really good investment for you, so that you can release your product at an early time in the market, which will benefit you to reap more out of your product sales.